Okay, so now that we know how to solve some quadratics, we have three ways to do it: factoring, completing the square root property. Right? Let's review the idea, the application of finding an x-intercept. So recall what an x-intercept is. If I go to my xy plane, what we're trying to find is where, right, on the x-axis does my graph cross the x-axis. So since we're talking quadratics, they're degree 2 polynomials. In the past, we've seen that these are classic U-shapes. So I got a U-shape, and so I'm asking myself where, right, does this U-shape cross the x-axis? Of course, algebraically, that's what it means visually, but algebraically, if I don't have a graph, right, it's kind of hard to find the x-intercept using a picture, unless I can make the picture. But algebraically, what happens is essentially y is equal to 0. To be on the x-axis, that is what makes me on the x-axis. The y-coordinate is 0 at these locations. Of course, that means functionally, we're talking about f of x equals to 0. So we're back to some function notation, which you see builds an equation, which puts us right into our wheelhouse. So let's find some x-intercepts. So again, how do I find the x-intercept of this function? Well, everything begins by setting f of x equal to 0. So here's what f of x is equal to. So this now creates the equation x squared minus 4x equals to 1. And so, again, to solve this, I would love to factor, but it doesn't factor very well. As a matter of fact, it doesn't factor very good at all. The x squared has this extra term here, so using the square root property, it's not really set up for that. So right now at this stage, the only way we know to solve this is completing the square. So that'll give us some more practice. Lead coefficient's already 1. These need to be isolated, so I'll add 1 to both sides, and we get x squared minus 4x equals to 1. So to complete the square, I'm going to take that negative 4 and divide it by 2. Again, hold on to that number. It plays an important role for us. To find the area I need to add, we square it, getting us 4. So to complete the square, I'm going to add 4 to both sides. This is now a perfect square trinomial. We use that to factor it, so it's x minus 2 squared equals to 5. So there we have it. So now we can use the square root property. It's nice and set up for it. So I'll take the square root of this side. I've introduced the plus or minus on that side. So we get x minus 2 equals plus or minus the square root of 5. It doesn't matter which root I use. We're adding 2. And so x equals 2 plus or minus the square root of 5. So I have two x-intercepts. Remember, these are points. So one of the points is 2 plus the square root of 5, 0. And the other would be 2 minus the square root of 5 is 0. So they're not very pretty, but they are real. Square root of 5 is roughly about 2.1-ish, right? Because we know the square root of 4 is 2. Square root of 5 would be a little higher. So if I was graphing this, this number would be 2 plus about 2.1, so that's about 4.1. And then 2 take away 2.1, well, that would roughly be about negative 0.1. So again, we're expecting a parabolic shape, but I know that this graph, whatever this graph looks like, it's crossing the x-axis at this location and at that location. All right, of course, you can bust out a calculator and get a better approximation. I'm just the big piece is what I'm interested in. All right, so there you go. All right, so next one, we begin, and you can see I already started that. We're going to start with saying that g of x is equal to 0, which basically means that the equation is equal to 0. My leading coefficient is not 1, so I have to handle that by dividing everybody by 2, right? And so that gives us x squared plus 2x minus 5 equals 0. Isolating, we add 5 to both sides. We get x squared plus 5x equals 5. All right, 2x. So now to complete the square, I'll take that 2 and divide it by 2, giving us 1. Squaring it, we get 1. So what completes the square is I have to add 1. Whatever I do to one side, I do to the other. So we end up with x plus 1 squared, right? That's a nice perfect square trinomial now, equals 6. I now can use the square root property, and we get x plus 1 equals plus or minus the square root of 6. Subtracting 1, we get negative 1 plus or minus the square root of 6. So where are my x-intercepts? One of them is at negative 1, plus the square root of 6, 0, and the other's at negative 1 minus, minus the square root of x, 0. And again, kind of just guesstimating, how about we say 6, the square root of 6 is probably like 2.2-ish or 2.3. Again, I'd bust out a calculator to get a better approximation. But, let me just use that. So it looks like the first one, if we take negative 1 and we add about 2.2, right, that's probably about 1.2-ish. So one of my x-intercepts is roughly about there. If I take negative 1 and I subtract 2.3, that's a little bit past negative 3. So again, we're expecting a U shape. I'd have to do some more graphing to get more accurate, but I do know that this graph is actually crossing the x-axis at those two locations. So there's one of our first applications of using our process of being able to solve a quadratic. It helps us in this case find x-intercepts, and it just so happened we needed completing the square to finish this off. All right, so well done, and I'll see you guys. Let's move into 11.2, and let's find an easier way if we can to solve these quadratics.